All right, we've seen one special case with factoring, the difference of squares. But then you also have a perfect square trinomial. So that's the following. You've got a value at the beginning and the end that are both perfect squares. And then you have this middle term. So the way this works is, if you were to take a look at this example, 25x squared plus 20x plus 4, we know that 25 and 4 are both perfect squares because 5 times 5 is 25 and 2 times 2 is 4. So what we do here is you're going to set up your two binomials. The first term is going to be 5x in each one. The end is going to be 2 and 2. So if you look at the middle, you see how there's a plus sign in between? We're actually just going to put plus plus. This just means that when you take that 5 and that 2 and you multiply it, you get 10. If I double that, you then get 20, which is that middle term, 20x. So let's look at another one. All right, example 2. So we're going to first look at the first term and last term. One you have x squared, the other one's 121. I know that x times x is going to give us x squared. Then I look at that 121. So I ask myself, what times what is 121? This is just 11 times 11. So then, in between the x and the 11, I put plus sign. Another way of writing this answer is just saying x plus 11 to the second power. So you're done factoring. So let's look at the second one. Example 3 on this page. We're going to look at the first term of 4x squared and the last term of 144. So we know 2 times 2 is going to give us 4. I'm going to attach x's to each side. 144, 12 times 12. We put 2 plus signs, and then we're done. All right. Another type. So sometimes you're not going to know what the middle term k is. So what we have to do is think about, if we were to factor this, what do we have? So the first is 4. So we're going to do 2 times 2, and we'll put an x with each of those. And then 81, well, 9 times 9. If we go back to that original pattern, that 2 times AB, if you take the 2 and multiply it by 9, you're going to get 18. By doubling that, you get the value of k. So k equals 18 times 2, which is 36. Okay. Then, what happens if we don't know that last number of k? So you need to look at that middle term. So in this case, we have negative 10. If I take half of negative 10, I'm going to get negative 5. Negative 5 is that value that I have to square. So if I square that, because that's the value of b, you're going to get the value of k. So k equals 25. The biggest thing with these problems is you need to know your perfect squares. 25, 16, 36, 144, those numbers that we talked about. All right, last one. So there's two parts to this problem. One, we need to factor it. So let's just look at that first part and forget about the equal 0. So if we set up our two binomials, you're going to have a 2y and a 2y, and that comes from that 4y squared. Then we look at that last term. You've got 49, so 7 times 7 is 49. I'm going to make these both negative because that middle term is negative. Sorry about the bell. And that's going to equal 0. So then you're going to take one of your binomials, because they're both the same, set it equal to 0. Now solve for y. Add 7 to both sides. You get 2y equals 7, divide by 2 on each side, y equals 7 halves, or 3.5. And we're done.